can see that there's half a screen of white and half a screen of questions.
Yeah.
Let's roll. Okay. If I'm answering questions and you're thinking, because I've not seen any questions before either, so it's good for me in the fact that it's new questions that we can get ourselves challenged with. But if you are thinking, oh my God, where did he work that out from? Or I do it a different way, or I've got it wrong, please shout out, or if you want me to break things down. So as I said, we've got a non-calc and we can scroll through that and see there's five questions on this one, and it's 15 marks in total. And you'll probably find, yeah, there's a 5 marker there. That's the most they're going to be for non-calc. I don't think there'll be a 6 if there's a 5. No, there's another 5 there. And a 1. So there's ranging from 1 to 5 marks. Obviously, if you are unsure about any of the questions in an exam and it's a 5 marker, I would say have a look at it and see if you can answer part of it, because you want to try and pick up, even if it's a 5 marker and you don't know what the final answer is, you want to pick up some marks to show that you've attempted it. Right, so let's have a question 1. Richard studies online. What's that doing now to my pen? He must complete 3.5 hours of learning each week for 32 weeks. Calculate 3.5 times 32. 2 ways of doing this. Perhaps change my 3.5 to 3 times 32. And that is going to be 96. And then 3. Oh my gosh. And then, okay, we can do that. 32 times 0.5. That's the half. 32 times 0.5, that would be just half of 32. That's 16. And we just add both up. So that's the first way we could attempt it. 9, that's 10, that's 11. The second way, we could just show it as a 35 times by 32. And then once we've got the answer, so we've taken the decimal place out. We'll do it as a normal double digit multiplication. 5 times 2 is 10. 3 times 2 is 6. Add our spare is 7. Then because we're timesing by 10, we put the 0 in here. 3 times 5 is 15. And then where are we at? 3 times 5 is 15. 3 times 3 is 9. Add our spare, that's 10. So we're going to add those numbers up. 1 and 0 is 1, and 1 and 1 is 1. So we said we take the decimal place out. So we times this number by 10. We put that in there. So to put it back in here, we divide it by 10 and it becomes 112. So that's the second way. Is there a third way? I'm trying to think, would I, without a calculator, I'm probably thinking, no, it's only 1 mark, so they're not looking for kind of in-depth calculations. They're looking for you to work it out and move on fairly quickly. With number bonds, I kind of break things up in my head, and so that's why I see that part first. So I'm doing the 3 times the 32 and then the half times 32 or half of 32. So for me, that way is slightly easier. I mean, you didn't have to take the decimal place out there. We could have done it as 3.5, but it just, for me, taking a decimal place out of a multiplication means I'm not worried about it whilst I'm doing the calculations. I know I've taken it out. Yeah, so I know I've got to put it back in when I finish. So as long as I remember where I've taken it from, like I've taken just 1 out, so that's times it by 10, we just put 1 back in. So it's sometimes more confusing doing it that way, but it's recognizing how you want to break it up for the first way. So let's roll into the next question. The 5-pointer. So they set you off nice and straight, well, nice and straightforward with a 1-pointer, but then they say, right, you've done a 1-pointer, now you can have a go at a big 5-pointer. So the course costs £5,000 in total. Richard pays a deposit of a tenth of this amount as a deposit. He will pay 30% of the remaining amount in the second term, and he'll pay the rest of the amount owed in the third term. How much does Richard pay in the third term? I've seen this question before. Right, so, but honestly, you'll think of this as being, right, when we break this down, you're like, oh yeah, right, so £5,000. He's paying a 1/10 deposit. So 1/10, and we're working out anything like a 1/10 or 10%, we're just literally dividing that number by 10. So when we divide a number by 10, we just literally, I was going to cross it off, we just cross a naught off, and it becomes 500. So let me put that note back on. So £500 is 10%. So we've divided our number by 10 because we've got 1/10. If we want 2/10, we just times that number by 2. We want 5/10, we just times that number by 5. So we know once we divide it by 10, we've got 1/10. He will pay 30% of the remaining amount in the second term. 30% of the remaining amount. So if we paid £5,000 in as a deposit, £500 a deposit, sorry, not 5,000, he's then got £4,500 left to pay. In the second term, he pays 30% of that. We're still working with this number, and you might think, well, no, we're not. We're working with 30 now, Steve. Well, no, we're still working with 10 because, like I just said up here, if we need 10%, we divide it by 10. If we need 20%, we would just get 10% and times it by 2. So if we go divide by 10 again to get 10%, let's knock a naught off. So we now know that 10% is £450. 10%, okay, so 10% equals 450. 20%, we just double. We double that one, so we double this one. And if we want 30%, quite simply, we add another 450 onto that, because we're just timesing that by 3. And if we add 450 onto that, rather than put 450 times by 3, which you can just simply add those two numbers up over there. So we've got a 0 add 0 is 0, 5 add 0 is 5, and 4 add 9 is 13. If we'd have done it over here, 3 times 0 is 0, 5 times 3 is 15, 4 times 3 is 12, add our spare. So we get the same amount, but hence why, again, lots of questions can be done in multiple ways. So it's finding the way that is most appropriate for your level of understanding, as in, like, I said to you before, I like chunking numbers up. So I like breaking things down and doing things. It might take a bit longer because I've chunked it. I've got to do 2 sums, but it's making each chunk simpler. So finding 10%, divide a number by 10, yeah, that's easy. So if I don't want 30%, whoa, I'm straight away, I'm thinking, if I've got a calculator and I wanted 30%, I put this number in my calculator and I times by 0.3, because that is 30%, but I don't have a calculator. So hence why I found out 10% first, which is £450. 30%, we times it by 3, is that. So we now know that of the remaining amount, £4,500, he then went and paid £1,350. If we do that as a normal takeaway, not take away naught remains at naught, not take away 5, we can't do it. So we cross the 5 out, we put a 4 in its place, and we park the 1 next to our 0. 10 take away 5 is 5, 4 take away 3 is 1, and 4 take away 1 is 3. So the remaining amount he's got to pay is 3,150. And if you weren't sure, if you think, I don't know if I worked that out right, put in your amount you paid on term 1, put in your deposit, and see if it gets back up to 5 grand. 0, hope it does now. 1, 9, 10. 3 add 1, add another 1, it's 5. So we've checked back on our answer. Again, you might not have time in the exam to do that, but it's just one of those things where we're just totting it up as we go along. And with the NCFE exams, sometimes the hardest part is when I say reading the question, I don't mean literally, reading it as in like talking through the words. I mean picking out what it's wanting and what it's not wanting. So step one, so for 5 marks, step one was to find a tenth. So if we only got to that point where we'd found out our deposit was £500, you'd get a point for that. You'd miss out the earnings of 4. And then you're going to get another point, sorry, for looking at 10% or showing how you're going to find 30%. So if you found out what 10% was, you get another point. If you've got to the 30, you get another point. And then if you've taken off your 30% from your sum, you get another point. And then you found out your answer. How much does Richard pay in the third term? If you put that in the right at the bottom, 3,150, you get your, so 3,150 to pay. You get your 5th point. So in theory, you're getting that point twice. But if you don't write, and this is where some people do make an error, they've done all the workings out step by step, shown it absolutely perfect there, and missed out that bit there because they've written it here. They think, oh, that's okay, I've written it here. No, you need to write it in there as well. So that question is a biggie, but depending on how you broke it down or how much you recognize the process of finding 10%, that question would be either very difficult or relatively straightforward. So it's just timings. Roughly a 5-point question could be about 10 minutes. We normally say that if it's worth 1 mark, every 1 mark, it's worth 2 minutes because it's 15 marks for a 30-minute exam. So if we really smash that one really quickly and it took us 1 minute, in theory, we gain an extra minute here. But if this one took us 12 minutes, it's not to worry as long as you got to the end point, as long as it's not taking you 20 minutes, because it doesn't leave you long to do the rest of the questions. But you'll find the more you see practice exams, mock exams, and look at the types of questions they're asking, you'll see that actually the math doesn't really change. It's Richard changes to Sarah, watch it videos changes to trees, and so things like that. They're not really changing the numbers too much or what you have to do. They're just changing the topic and the names of the people. So my advice is use I'll send this site out because I'm going to say these are new exams. I'll send this site out to everybody, and it's good to have a look at them. And by all means, if you have a go at them and you want me to mark them, either type in the answers in the box or do what I'm doing here, do another sheet. As long as you tell me which exam it was you were doing, more than happy to mark a mock exam or a practice exam, I should say. Okay, let's have a look at the next question. Richard must watch some videos. Table shows the number of minutes each video lasts. What is the range? So when we talk about range, I'm thinking, right, range. I always think of it as being, if I'm doing something many, many times, am I going to get exactly the same answer every time? Well, if I'm running a marathon, not that I'm ever going to run a marathon. I don't know, let's do something easy. If I'm running around a track once, am I going to get exactly the same time? No, I'm going to get a range of times. So when you're talking about the range, we're looking for the highest number, take away the lowest number. We're looking at the space between, well, let's hit my plant, the biggest number and the smallest number. So we'll find the biggest number on this list. 42. I see a 42. Any hands on some 42? No. So 42.2. Take away lowest number. We got a 25. 25.5 is the lowest. And we don't need to get rid of the decimal place in this one. We can keep it as it is. And we can do the same rule as in a normal subtraction or takeaway. 2 take away 5 we can't do. We have to borrow 1. So that goes to a 1, and we take the spare 1 and put it there. So 12 take away 5 is 7. The decimal place remains in the same spot. So we don't do anything with that. We just put it in. 1 take away 5 we can't do, so we have to borrow 1. So that goes to a 3, and that is now 11. 11 take away 5 is 6, and then 3 take away 2 is 1. So the range of all his minutes that those videos last is 16.7, and it gives you the measurement there, or the minutes, but we'll put it in there. It gives you that, so you just put your 16.7 in there. So range of the averages question, mode is most common. I quite like that one because it's easy to work out. You just look, see which number occurs the most. Whereas range, I think, is the second easiest because you're only looking at the very highest and the very lowest. Whereas median involves all the numbers, putting them in order, and mean involves all the numbers. You've got to add them all up and then divide it by the number of. So range, I think, is the second best averages question to get. A 2 marker, I mean, that's a bit. That says a 7. I'm sure it says a 7. I've had this before with these printouts. You've got to make it big or small. No, maybe you got to make it small to make that number. That's even worse. Can't even see that Pimpernec's tiny. I am almost certain that that is a 7, and the bottom one is 3/4. So if we say it is a 7 and we work it out as a 7, then we're going to be okay. That's a D, by the way. That's not even a very good D, is it? Right. Richard looks at the marks for his first 2 assignments. He achieves 7/10 for his first one, so number 1. And then he achieves 3/4 for his number 2. Richard says he did better on his first assignment. Is he correct? If we think about this number and having to change it or make it bigger, when it comes to fractions, you can, if you know what they are in decimals, if we look at that as a decimal, 7/10 is actually 70% and 0.7. So 70%. It's saying 7 pieces out of 10. So if we times them both by 10, we'd have 70 pieces out of 100. So 70 pieces out of 100 is 70%, or 0.7. 3/4. So when we're talking about 3/4, we're talking about 0.75. We're talking 75%. 3/4, 1/4 is 25%. So we're talking splitting 100 into 4 equal pieces. 25 times 4 is 100. So 3 times 25 is 75%. So we can now see that Richard is not correct because we've changed them both into decimals, and that's not with any math. I've not done any math there whatsoever. It's just understanding equivalence. So understanding. And the reason I write fast is because I can't spell. Understanding equivalent, fractions. I'll try and write this better. Fractions, decimal, and then percentages. Right. If we were not sure about equivalence, or we're going to think, oh my gosh, there's 2 weird looking fractions there. What the heck can I do? Then we might try and make this denominator the same, because then we can look at equivalent fractions. So if we were to set them out a little bit differently, we're going to set them out. Where's my pen? We're going to set them out side by side. We're not going to add them. We're not going to take them. We're just going to change them into the same number at the bottom. So the way we do that, we look at this number times by this number. So 10 times 4 is 40. Okay, so we're now putting both our fractions in 40ths. Whatever we times this number by to get to that one, which was times by 4, we've got to do the same with this one, times by 4. So 7 times 4 is 28. And likewise with this one, whatever we did with this one to get to 40, we times by 10. We do with this one, times by 10, 30. So, it doesn't say 36, but I'll change it because it looks a bit like it could be disguised. 30. Okay, so now you can see without doing that, oh yeah, I know what 7/10 is off the top of my head. It's 70%, or it's 0.7. Oh, I know what 3/4 is. It's really clear We've done a bit more math. That one was no math. That one was just memory and knowing. This one, we did a bit of math to look at the exact equivalent. So now we know, we can see that 7/10 is the same as saying 28/40. 3/4 is the same as saying 30/40. And we can see that this one is bigger. Not by much, but it's bigger. So we were right to say that Richard is wrong because this one is bigger. So there's two ways of working that one out. Richard incorrect. Richard incorrect. So sometimes when you recognize smallish fractions as being what they are as a decimal or what they are as a percentage, that one can save you that 2 marks, potentially 4 minutes. You could probably have done that question if you knew those equivalents in 30 seconds. You can say, oh yeah, well, that's 70%. Oh yeah, that's 75%. That is wrong. Let's go. Next question. But if you weren't sure, we look at making our denominator, the bottom number, the same. And sometimes if it hadn't said 7/10 and 3/4, if it said, I don't know, let's think of a random fraction, 7/13 and 9/16, we would do the same process. We'd have to make them both the same denominator, which would take a bit of time on non-calc because we'd have to start doing some multiplications at the side. But working out equivalent fractions might seem scary, but it really isn't. It's really just a case of following a process. Right. Peter is running an online course. There are 560 students on his course. I 100% have seen this exam, but I'm sure they just changed the names of people and things. There are 560 students on his course. The ratio of full-time students to part-time students. The ratio basically means we're breaking something up into pieces. Okay, so 560. That's a bad 5. I'm not doing very well with my writing today. 560. So full-time, we want 3 pieces, and part-time, we want 4 pieces. So we're breaking it up into pieces. And if you look at that, we need 3 pieces and 4 pieces. So we need 7 pieces. When I'm talking about pieces, portions, whatever you want to call it, we need to break this number down into 7 equal portions because we need to know how much each portion is worth. So the first thing I do, I'm going to go 560, and I'm doing a bus stop. If you knew, oh my gosh, my brain's gone friend. If you could work it out in your head, absolutely do that. If you can't, and say if you don't even know your 7 times table, we'll write it down here. 7, 14, 21. There's no, and again in an exam, you can make whatever notes you want. There's no offense to write any notes as long as it's nothing rude. We'll go there. My brain's not thinking straight. So as you can see, we've already come to a number there. If we write our 7 times table down, that actually looks a bit like this one. So if we were, and again, there's 2 quick ways of doing this. We can carry on doing a bus stop method, or we could think, actually, if I take that off, where's my thing gone? It's 8 times. 1, 2, 3, 4, 5, 6, 7, 8 times. Oh, I had a 0 on the end because it was 560. So I need to put a 0 on here. If that was the case, amazing, because we just recognized it when we did our 7 times table. If we didn't, and we didn't write that down, then we do it like exactly the same way, but we do the bus stop method in full. 7's into 5, don't go. 7's into 56, so we do that stage now because we don't have the 0. 7's into 56, we go 7, 14, 21, 28, 35, 42, 49, 56. Oh yeah, it's 8 times, so we'd say 8, and then 7's into 0 is 0. So we still get the same answer. We just worked with our 7 times table. So when we've done this now, we know that if we split 560 into 7 equal pieces, equal portions, each portion is worth 8. So 1 portion equals 80. Okay, with full-time, let's scroll down a little bit. I'm not going to get a chance to put that table in. We know that full-time portions, full-time is 3 portions. So full-time equals 3 portions. Pieces, what you want to call them. So that is 3 times 80. So that's 240. So 3 times 8 is 24. Add the 0 on the end. Part-timers is 4 portions. Try and write that a bit neater. 4 times 80 equals 320. If we weren't sure, if we worked it out right, again, we add those two numbers up and we get what we started with, 560. So we're on the right tracks. Okay, we've now figured out, if I could fill this, can I fill that in there? Can I just draw a grid like that? It's not very straight, but I can go 1, 2, 1. Oh, that's a bit of a wobbly one. So that's first year, second year, total, full time, part time, total. So we know this number already. So the total number of students was 560. We've got that sorted, done. We then know that the total number of full-timers now is 240 because we've just worked that out as well. And we now know the total number of part-timers is 320. So we've got, it's like Sudoku. We've got 3 numbers in our Sudoku grid. We just need to work out the rest. It says there, and this is where sometimes I think the maths exam becomes an English exam, because it's like, what? Why have you given me in words? Just tell me in math, in numbers, what I've got to do. It's saying 3/5 of part-time students are first years. We know our part-timers, oh my gosh, part-timers is 320. Okay, we need 3/5 of that number without a calculator. So again, that might seem scary, but if we think about fifths, that means dividing a number by 5. It means we need to split it up into 5 equal pieces for 1/5. We need 3. So once we found out 1/5, we just times it by 3. So 5's into 3, don't go. 5's into 32, 5, 10, 15, 20, 25, 30, 6 times. And I've got 2 left over because 30 would be my number. I've got 2 left over. Okay, 5's into 20, goes 4 times. So I know that 1/5 is 64. But I want 3/5 because I want the number on top. So I need to times that by 3 to find out what 3/5 is. 4 times 3 is 12. 6 times 3 is 18. Add a spare, 192. So it says here 3/5 of part-time students, part-time, are first years, 192. I don't really need to work out this spare number here because I can just say actually it's the gap between that and that, or it's 2/5. If 3/5 are first years, then 2/5 are second years. Oh my gosh, second years. And so I've got 1/5 is, so I can go 64 times by 2 to get my other spare number, if you weren't sure. So that's 8, and then that's 12. So 128. If you didn't know that that was how to work out the second number, and you thought, actually, I'm pretty good at Sudoku, if I'm going along a line, it needs to add up to that bit at the end. And that's not quite Sudoku. But if I got 320 was my total, and I knew that I already had 192 pieces of that, I can go, well, I can't do that one, that's 1. 10 take away 2 is 8. I can't do that one, that becomes a 2. 11 take away 9 is 2. 2 take away 1. So I can still do it that way, Sudoku way, where I'm looking at what numbers left to put in that hole. But if you know if it's fifths and you want 2, you've got 3 already, you just would times it by 2. Okay, so we now know that everything we've got so far is up to this point here. The total number of students in the first year of study is equal to the total number of students in the second year of study. So that's quite a confusing statement, because we've got part-time students, we've got full-time students, we've got first years, we've got second years. Okay, so think about what it's saying. It's saying the total number of first years is equal to the total number of second years. Doesn't matter about these two numbers we've already got. It's saying the total. So these two numbers are the same. Okay, and if we think if these two numbers are the same, they have to add up to this total one here, because this is our Sudoku game, so they have to add up to that. So to find out what these two are, we can just go 56 or 560 if you want, divided by 2 to find out what it is. 2 is into 5, goes twice with 1 left over. 2 is into 16 is 8. 2 is into 0 is 0. So we now know that when we split our 560 into 2 equal parts, those two numbers are there. And quite simply now, we can do the Sudoku part, or where we've got to make sure we add those numbers up. If we go up there, can I move? I want to try and keep it on screen. I'll stick this one here. So we can now see if we already knew that full-time, on the information it gave us about full-time students was that number there where it said it was worth 3 pieces. But now we don't need to do anything else other than take that number from there and that number from there, because we know the total has to be 280. So let's do it, mate. Let's do it here. 280 take away 192. Okay, we can't do that one. That becomes a 7. It becomes a 1. 10 take away 2 is 8. 7 take away 9 we can't do. It becomes a 1. 17 take away 9 is 8. And then 1 take away 1 is 0. So we can't do that. So that number is 88. And then if you think about this, you could either do that, take away that, and again, this is where it's like Sudoku to get this number, or you could put that, take away that. It doesn't matter which way around, because it all has to add up. It's like you might hate Sudoku. I can't do crosswords. My English isn't what it should be. But yeah, I can definitely do. I quite like a bit of. I'm on holiday. Yeah, Sudoku is I can't read a book. It gets all sandy and watery. Sudoku is easier. 280 take away 128. 0 take away 8 I can't do, so that goes to 7. That goes to a 1. 10 take away 8 is 2. 7 take away 2 is 5. 2 take away 1 is 1. 1, 5, 2. Okay, so with that question, there wasn't any, how do I word it? Wasn't any kind of strict way of doing it other than knowing that bottom number they have to add up to 560 and that number they have to add up to 560. So knowing that the rules of a table, the total is given to you, and you kind of work backwards from that. So if I was doing this question, I'd put that number in first, that was my total, and then I'd do my ratio where I did here, look, split it into equal portions. And when we say equal portions, well, that's a 3, that's a 4, that's not equal. No, it isn't, but we need to split this number into 7 equal portions, because I'm going to need to allocate 3 portions to full-time, 4 portions to part-time. So that question is worth 5 points, and I think that's the end of the section, but I think that's a big question, especially when, well, if it wasn't printed like that, that'd be a moan, because I can't really see that's a 3/5. But this one here for me, that sentence there is not maths. But unfortunately, that's the way we have to do it. It is maths, and that's the way that they kind of present themselves. But I just think that's a bit too Englishy. If I don't have the grasp of, I sometimes read really quickly and miss one word out, and that can change the whole concept of the question. So yeah, if it's a question like that where you think there's no numbers there, what's it asking me? Read it several times and think, right, how can I break it down? So rather than mark what we've got, because all these papers that you can download actually have the ability to be marked yourself if you wish, or you can say if you send them to me, I'm more than happy to mark them if you think, yeah, I'd rather you mark them, because sometimes when you mark it yourself, you yeah, I nearly got that answer, and then you just write it in. Right, so can we now put that one as a big one? No. What? Let me find the other one. We'll just do a few questions of this one, or we'll see if we can get through a few, I should say. Right, let's put that back as half, and then, oh, it's not letting me have that one. Let's move that one out of the way. Try again. That one is half, and then this one. There we go. Okay, so as you can see, this one, hour and 30. When it's online, you don't have to kind of open another page. You just click next and next again, and you're in. And the tools online, I would say the NCFE, the only bad thing about the NCFE is you need to have your own calculator. It doesn't need to be a scientific calculator. It can be a bog standard with just nine, well, not nine numbers. You got zeros, 10 numbers, and the add and the take away, and then divide and the times. It doesn't have to be something big. It's just a normal calculator. You can't use the one on your computer because basically, when you log into the Proctor server, the NCFE, it's a secure site, so your screen basically freezes onto the exam, except for next, backwards. So yeah, your computer becomes non-workable, and you're not allowed to use your phone because obviously you could then type in the actual equation or the actual question, it'll give you the answer. So yes, it's a tricky one, but again, if we were to move examinating boards, then they might have different rules. I know Pearson have an inbuilt calculator, but I always think their questions are a bit harder. So it's just there's loads of examination bodies out there. There's Aqua, there's NCFE, there is Pearson, and they're all slightly different. So for me, Atom, the system that we kind of encourage people to do all their little topics on and units on, really marries up well with the exam style questions in NCFE. So hence why we chose those two platforms together. Okay, let's have a look at a few. Oh well, we've got 20 minutes yet. We can have a look at a few. Right, so we're going to put calc now. We'll put calc, so we know we've changed. And let me go to the top of my thing, so I know it's calc. I'll just put like that, so I know it's both. Okay, we'll scroll down. So let's have a look at the calc. Again, there's a range of questions. Generally, when you're allowed to use your calculator, I would say if you know it in your head, use your head and then check on your calculator. If you're not sure and you like to use a calculator to make sure you know you're doing the right thing, then absolutely use your calculator. Let's have a look. Can we move it there a bit? No, because if I click on there, it'll go onto there. Can I make it a bit smaller? I just want to try and have it. Let me close it down for a minute. Okay, it's there, but I was just trying to read the question and show you how I'd work it out. Sahara. I'll call her Sahara. If somebody's got that name and it's actually Sarah, I apologise. But Sahara, she needs to build a ramp to make rooms more accessible with a wheelchair. So Sahara needs to work out the length of the ramp. She has this rule: rise of step in inches multiplied by the scale factor equals the length of the ramp in centimeters. So we've not, again, we don't have to remember anything here. We just have to say, put it in the machine, rise of step. Oh, wow, that's not working. Rise of step is 6 inches. So 6 multiplied by the scale factor times by the scale factor is 30. Sorry, I just had a door slam in my house. That means somebody's left windows wide open upstairs. It wasn't me. 6. So we've put the numbers in the machine. We've got 6 multiplied by the scale factor 30.48, and we've got the length of the ramp. 6 times 30.48 equals 182.88. 182.88. It then doesn't need us to do anything else. It just says how long is it in centimeters. 182.88 is your answer, and there's nothing else to do there. It's just following the machine, following the formula machine. You don't have to think of anything else. That's just it. Done that one. And you quite often get questions like that. It might be where you have to convert Fahrenheit to Celsius, but you don't have to know the formula because it gives it here. Let's say Steve's on holiday. I don't know, Steve's on holiday. The temperature on the beach is whatever in Fahrenheit. He wants to know if that's warm enough to go in the sea. It has to be 30 whatever degrees Celsius to work it out. And that's, or they do it. And there's a question where we've got an iron where it's somebody set the iron temperature and he has to kind of he set the wrong temperature, he set it on Celsius, it should be Fahrenheit. How much more degrees do they need to turn his iron up? Things like that, right? So we're on B. The diagram is of a ramp. If it's unfolded, which one does it look like? If I look at this question, I'm discounting one straight away. I mean, we can discount them all except for the right one, obviously. We're discounting that one straight away because it's got no triangles in, no triangles. So definitely not that one. If we folded that up, we make a little cube, a box. If we go to B, I'm thinking, right, I'm folding these two parts up. So it's like that. You're back. And that's the flank. So I'm so far saying B is B. However, we check. Okay, so fold that up like that. Aha. So now I've got the problem straight away. Because look, my right angles on this diagram are close or touching the other side. So my right angles are here. So it's not that one. It's close, but it's not. Whereas this one, look, it's not got the right angle symbol, but I can see there that it's definitely square there. So it's not that one. And when I look at that one, I'm not sure what that would be. That's like a tent. Yeah, that's so it's definitely not a tent or a Toblerone. That's better. It's not a Toblerone. I wish it was, but it's not. Okay, so it has to be B because if we folded it up, in our minds, what do we see? We see that ramp. When we fold that one up, we see a ramp, but not the same. It'd be a slope on this side as well. Let's scroll down a wee bit. Right. Each guest can buy breakfast. Okay, each guest can buy breakfast for £10. They get a 15% discount if they pre-book. Calculate the cost of breakfast after discount. When it says calculate and you've got 15%, I'm not saying that's easier in your head, but if we've got 15% of 10, if you've got 15% of 100, that's 15. So 15% of 10 is 1.5. And if we were to say that, and again, knowing it's a number bond, as in like 15 of 100, 15% of 100 is 15. So 15% of 10 is 10 times smaller than that number. So that is minus £1.50, which is £8.50. Oh, wow. That sounds not bad, does it? £8.50 for a full breakfast. It has to be tea and toast as well with it. If you weren't sure, questions about food at this time of night are making me hungry. If we weren't sure how to recognize that as a number bond there, and we just do 10 take away 15% equals in our calculator. That's a percent, by the way. Let's get our calculator open. Here it is. It's peeping. 10 and oh my gosh, why is it 0.10? Shouldn't be. Follow exactly what I've written here. 10 take away 10% equals. I took away 10%. I'm thinking, my breakfast is more going up. It's 15%. Oh gosh, my breakfast has gone up in price already. 10 take away 15% equals £8.50. So we followed exactly what it is there and we punched those numbers into the calculator. And that's the second way to do it. On a calculator, you've still got £8.50. If you weren't knowing that number bond and you didn't know how to work your calculator with a percentage, which, to be honest, some calculators don't even have a percentage button on, so you can't. Let's think of it as this way: 10% of 10 divided by 10, so that's 1. And then if we say that 10% is 1, then 5%, we're halving that number. Okay, so we need to half this number. So if we half of 1, that's 0.5. So we add those two numbers up, which will get us 15. We add those two numbers up, which gets us £1.50. And then we just take that away from the 10. So there's 3 different ways to do that. Again, it's on a calculator. If there is other ways, and you might think, yeah, there's another way. If you're kind of good with percentages and decimals, then if we're thinking about 100 and we're taking away 15, that's leaving us with 85%. Okay, so straight away, when I'm looking at that, where am I here? 100 take away 15 is 85. So again, 10 take away 15 is 8.5 because I put in my decimal place in there. So there's loads of little, not tricks, but oh gosh, just, oh no, I've got rid of it all. It's just understanding that there's lots of little not rules, just little shortcuts that you can do. I mean, on a calculator, you could say it's 10 times 0.85, because that's 85%, so you're getting £8.50. Honestly, that sort of question, especially when it's only 15%, it's not like 27 or 33, or it's not, it's a quite a good number, because you've got 10 and then you've got 5 and you're working with a number 10 there. So yeah, think of it as being 10% of 100, or 15% of 100 is 15, right? So 2D. Again, similar sort of question. We're looking at percentages and decimals, I think I can see here. Sarah looks at how many guests have pre-booked breakfast over the last 2 years. Wow, okay. 60% of, right, so 60% of 1470, or 45% of 2460. Sarah says more. Sarah says this one is bigger. Is she correct? So the answer is yes or no. Now it becomes like a calculator question. If you want to find out a percentage of any number, we change it to a decimal. So if I've got that as a decimal, if I know that 50% is 0.5, so 60% has to be 0.6, 70% is 0.7, 8% is 0.8. So I know that that is that 6% is 0.6, and I'm going to just multiply it by my number. So I want 60% of that number. 45%, okay, same rule. That becomes 0.45, and I want to times it by that number. So I've now got, on a calculator, within 2 seconds, maybe not 2 seconds, but 5 seconds, 0.6, God, times by 1470. I know that 60% of that number is 882. And 45%, 0.45 times by 2460, 1107. So Sahara or Zahara or Sahara Desert is correct on this occasion. Yes, she's correct. So it's important on there that you've put yes in your box, not the answer. So is she correct? Yes. Show how you decide. You show how you decide would be your workings out. So finding a percentage of any amount ever in the whole world is change your percentage to a decimal. So if you see, like, I don't know, your online shopping, say, oh, it's 5% off. I mean, 5% is not very much, is it? So if you're looking at 5%, 0.05 of an amount. So you're paying like, oh yeah, it's £65, and I want to find what 5% is. I times my 65 quid that I'm going to pay for a, I don't know, pair of trainers or a pair of jeans. That shows how much shopping I do. 0.05 times by 65. So I'm getting a grand total. When it says, oh, 5% off just today, I'm getting a grand total of £3.25 off my trainers. So, and it's probably going to cost me 10 quid in delivery. So actually, I'm better just walking down the shop and getting them. So yeah, discounts and things like that. Work it out. Get your phone out, get your calculator out, work out what your discounts are going to be, and think, that sounds a good deal. Oh no, that's not a really good deal. That's rubbish. Yeah, when anything less than 10%, you're thinking, I know my delivery charge are going to be more than that. So they're just fooling me here. Or they'll say free delivery, and actually it's more expensive, so it's not, is it? So shopkeepers and internet shopping is a bit of a con. Right, we've got, let's squeeze in a couple. Is this the last question on this section? Yes, okay, let's squeeze this one in. We've got plenty. Sarah has 1.5 hours until the next guest arrives. She has 2 tasks to do in that time: clean the windows and vacuum. Yeah, I've got dirty windows from my dog. When it's been in the garden now, it jumps up at the window and it gets dirty paw prints, and she's upside down on the sofa, so she's not listening. It's okay. 70 add 15 equals 85. 85 minutes. How much time will she have left? So it's knowing this question. It's not a difficult question, but it's knowing that 1.5 hours, 1.5 hours is 60 minutes is the 1 hour. 30 minutes is a half hour. So that's 90. She's going to take 85 minutes. Flipping heck, it must be a lot of windows. Take away 85 equals 5. Wow. Oh, and this might be high up. I'll give her. I'll let her up. It could be a ladder. It's a big job. Got to keep moving your ladder and getting down. But it's a good workout. Oh no, there is this one. We haven't finished it. There is F. Okay, that's cool. F. Amazing. Oh, complete the pie chart. We can't really complete a pie chart on the computer version. You would have the tool. So your pie chart's there, for example. You'd have a tool that drags your lines left, right, up, down, things like that. So if you think about that one here, I'd probably do the 60% first. It's more than half. So I'm going there for starters. And again, the computer would, as you brought the wheel round, the computer would be telling you where you're at. So if it's 60, add 20, 20, let's go 20, 60 add 20 is 80. So let's go 20 would be there. That's my 60. That's my 20. Is that about? Yeah, maybe. And then I've got one lot of 10, so that's half of that one. So let's say that's there. And then I've got 2 5s. So I've done it. I could have done it. Yeah. So that one is meant to be the same size as that one, and those 4 are meant to be the same size as that one. So it's about right. I mean, I wouldn't say it's a masterpiece, but on a computer, you'd have the ability to make a line straight and actually have the data properly presented. That must be the last question. I know we've got G. Oh my God, this is a huge question. G, is it going to be good? Yeah, it's not a bad one, this one. I'm going to call this Sahara. Needs to buy 240 items to the hotel. Each item costs 73p. Estimate. So estimate doesn't mean guess. It means make your number more simple. So use your fraction to work out the approximate value. So it's not saying do that on your calculator, because we know if we tap that in our calculator, we're not going to get an approximate value. It's going to be an exact value. So if you were to put this as your answer for this question, you won't get any marks for it because you've worked out an exact value. So what are we going to do here? We're going to look at, if we say 0.73 as a common fraction, that's saying, think about what we just did above. We said about decimals, and 0.6 was 60%, 0.45 is 45%. So 0.73 must be, well, is, I'm not saying must be, is 73%. And 73% would be 73 pieces in 100. So when we look at that number and we're looking for a common fraction, 50% is a common fraction. It's nowhere near that one. 75% is a common fraction because 75% is known as 3/4. So when we've got 75 pieces in 100 or 3/4, that's a common fraction. But 50 out of 100 is a half. That's a common fraction. So 73 out of 100 is not a common fraction. It's unusual, right? So we've now saying estimate it at 75%. So instead of timesing it by 0.73, we just multiply it by 0.75 because that's 3/4 times by 240. And again, you might be able to do that in your head, as in like 3/4 of 24. Split 24 into 4 pieces in your head. That's 6 each piece, and then 6 times 3 is 18. Add a 0 on the end. Or you might think, oh, I'm just going to work that on a calculator. Okay, so that brings us up to the end of the session. But I'm 100% sure I've seen these questions, but I don't see it on my previous workings out. So maybe they've just reintroduced them. I don't know. It just seems a little bit familiar. I don't know. Loft conversion. Yeah, it asks you about skirting boards near the end. I'm sure it does. Skirting boards. Yeah. So I have seen it. They've just maybe just reintroduced them. Okay. Was that mind-boggling or was that okay? Let me just stop the recording. Let me just stop the recording. Where's my recording at? Let me stop my recording and let me